Hello, welcome to Proportional Relationships and Equations, topic 2-4. Our focus question today, how can you tell if an equation shows a proportional relationship between two quantities? And how can you identify the constant of proportionality in an equation that represents a proportional relationship? We are going to come back to that. So our first key concept. We've used tables and graphs to represent proportional relationships. An equation can also be used to describe a proportional relationship between two variables. Recall that when there is a proportional relationship between x and y is a constant multiple of x. This constant multiple is the constant of proportionality, what we talked about yesterday. So if we have the equation y equals mx here, if I divide both sides by x, the x's simplify, and I get my constant of proportionality to be y over x. And if you recall when we had tables, to see if the information in the table was proportional, we kept dividing y over x to see if we got the same constant or the same number. And if we did get the same number, there was a proportional relationship. So now we're going to work backwards. Since the value of y depends on the value of x, y is the dependent variable and x is the independent variable. Think about when you used to graph, when you began graphing. X was the independent variable and y was the dependent variable. That concept still holds true here as well. So let's show or decide to look at these and see whether each equation shows a proportional relationship. Meaning, are they in the form y equals mx? The first one, y equals 6x? Yes, it is. How about the next one, y equals 4x minus 5? No, because it's got the minus 5. The next one, y equals negative 4x? Yes, it is, even though it has a negative. That's okay. Do the next four for me, and then come back, and we'll check them. So this one is a yes. The next one is a yes. Still takes the form y equals mx. Same with 3x equals y. We just flipped the way we wrote it. We wrote 3x equals y instead of y equals 3x. And the last one is a no, because we have this constant at the end. So now let's look at a word problem. Your friend uses the equation y equals 8.5x to calculate the total cost y in dollars for x movie tickets. So x here is our movie tickets, y here is our total cost. What is the constant of proportionality in this equation? Our constant of proportionality, if we were to divide both sides by x, our constant of proportionality is 8.5. In this case, $8.50. And what does it represent? $8.50 is the unit cost or the price per movie ticket. Okay, so how much will 13 movie tickets cost? X represents our movie tickets. So we're going to replace X with 13. And when I do the math on that, we get 110.5. So in words I can understand, it would be a cost of $110.50 for 13 movie tickets. For the next one, the equation P equals 4S represents the perimeter of a square with side length of S. What is the constant of proportionality? and divide both sides by s. So my constant of proportionality is 4. And what is the perimeter of a square with side length of 1.6 meters? I'm going to substitute in 1.6 for my side length. And the perimeter would be 6.4 meters when I do the arithmetic. For the next set of slides, they want us to write an equation. A certain veggie dip contains 60 calories per serving. What equation represents the number of calories y in x servings of dip? So, 60 calories per serving, so y equals 60x. Okay. Y represents the number of calories, x represents the number of servings, so y equals 60x. For the next one, at a telethon, a volunteer can take 60 calls in 5 hours. What equation represents the number of calls y a volunteer can take in x hours? So let's show a little more work here. Y is the number of calls. Let's divide by x, which is the number of hours. The information they've given me is 60 calls in 5 hours. When I simplify that, 60 divided by 5 is 12, so I get 12 calls per hour. I'm going to move over to here, so y over x equals 60. I'm sorry, excuse me, y over x equals 12. And when I move the x over, I get y to equal 12x. So on this one, we had to find the constant of proportionality. On the first one here, they gave it to us. So I want you to try the third problem, and then we'll come back and check it. Okay. When I set up the problem here, I had to find the constant of proportionality. 60 divided by 12 gives me 5 teeth per minute. And when I plug that into my equation, y equals 5x. And my constant of proportionality keeps going in front of the x, the coefficient of x. You paid $2.50 for 5 apples. Write an equation to represent the total cost of cost y of buying x apples. Again, try this one on your own. I divided it up to find my constant of proportionality to be 0.5, so 50 cents per apple. So my equation, y equals 0.5x. When we travel to another country, you often need to exchange US dollars for the local currency. When you exchange money, you receive the equivalent amount in local currency based on the exchange rate. An exchange rate is an example of a constant of proportionality. Interesting, I bet you did not know that. Recently, the exchange rate for US dollars to Indian rupees was $1 is equal to 45 rupees. So the constant of proportionality is 45 rupees per dollar. Okay? So let's take this to Spain. We're going on a trip to Spain. When you ask for the exchange rate, your bank shows you the table. Write an equation you can use to find how many euros y you will receive in exchange for x US dollars. So the first thing we have to do, they're telling me y is my euros, x is my dollars. Okay? And I have to use that information to set it up so that I set up my exchange correctly. I need to find y over x. So when I do that, y is 3750 over 50. When I do my math on that, I will do it for you. 3750 divided by 50 is 0.75. Okay. The exchange rate is the same for all of them, okay? I did divide them all up. 75 divided by 100 is 0.75. 90 divided by 120, same thing. And 131.25 over 175. So when I go to write my equation now, y equals 0.75 x. X is my number of dollars. So if I went to the bank and I had $10 and I put it in, the bank is going to give me 10 times 0.75 or $7 or 7.5 euros. Okay? Now, let's look at it from the opposite way. When we return home, we have money left over. We want to use the table to write an equation where we can find out how many US dollars is Y. Ah, it's changed. Over X euros. So when I go to set this up, looking at my table, I can choose any ordered pair or any point. It's going to be flipped though. So if I have $50, 37.50 euros, when I go to divide it here, it's approximately 1.33. So when I come home, my exchange rate's going to be the opposite. Okay? For every euro I have, I'm going to get $1.33 back. Okay? The last topic we have to talk about is proportions. And we've already talked about proportions earlier in the last topic. A proportion is an equation stating two ratios are equal. You can use a proportion to solve a problem. Solving a proportion is similar to finding an equivalent ratio. Here's an example. In the average adult male, for each 5 pounds of body weight, about 3 pounds is water. How much of a 188-pound adult male is water? So we're looking, they give us the rate, or the ratio. Pounds of body weight for each pound of water. So we have body weight over water. Okay. So for each 5 pounds of body weight, we are 3 pounds of water. How much of a 188-pound adult is water? So water is in my denominator, so I'm looking for that. And I'm using a 188-pound adult. I'm going to cross multiply. When I do the math, or the arithmetic, 3 times 188 is 564. What I need to do now to isolate x is to divide both sides by 5. And when I do that, I get 112.8. So a 188-pound adult male is 112.8 pounds of water. Okay. On the next slide, I have 2 problems for you to practice right now. So pause it, answer them, and then we'll come back. Okay, let's see how you did. I wrote it on my first one. I'm looking at the goalies to the total number of players. 2 goalies for every 30 players. How many goalies is my x over 915 players? I cross multiplied. I divided both sides by 30 at this here, and then I went up to my arrow and I got x to be 61, so there's 61 goalies. For defensive players, there's 9 defensive players for 30 players total. How many defensive players are there? If there's 890 players, I cross multiplied and divided, and I get 267 defensive players. So now, let's move up to a focus question. How can you tell if an equation shows a proportional relationship between two quantities? It's written in the form y over x equals a constant, or, excuse me, not a c, an m. Or y equals mx, okay? And the constant of proportionality in an equation, the constant of proportionality is the m, as long as it's in the form y equals mx. That's everything for today. I look forward to working with you tomorrow in class. Have a great night.